All right, so in this video, we're going to talk again about hypothesis testing, but this time instead of using p-values, we're going to use rejection regions. And same as before, these are for large sample size, so sample size is greater than or equal to 30. So before we get started, we'd like to thank our corporate sponsors, Sticky Feet Reptiles, stickyfeetreptiles.com, and we have a new sponsor, the Crafty Badger, so we'd like to welcome them aboard. In order to use rejection regions, we're doing a z-test because our n is greater than or equal to 30. These are the steps that we're going to go through. So the first step says that we want to state the claim. So same as before, h sub 0, h sub a, identify the null and alternative hypotheses, and make sure you state which one's the claim. The level of significance they will always give us, that's our alpha. Make sure you specify that. Sketch the sampling distribution. So we know we have a normal curve. So sketch the normal curve. Determine the critical values, which is the new step here for rejection regions. And then after that, determine which way is it going. Is it going left-tailed, right-tailed, two-tailed? Sketch the actual rejection regions in. Find the standardized test statistic, which will be our z-score, and then make a decision based off of the rejection regions to either reject or fail to reject the h sub 0 or null hypothesis. And then, of course, as always, we want to take that back and interpret what that means in the original context of the problem. So this is our first example. It says a fast food restaurant estimates that the mean sodium content, so we know we're going to be using mu, is in one of its breakfast sandwiches is no more than 920. So no more than, what does that mean? Well, no more than, that means less than or equal to. So our h sub 0 is going to be mu less than or equal to 920. And that is my original claim. So like before, I'll just put a little c in for my original claim. Well, what's the opposite of less than or equal to? Of course, that would be greater than 920. If we keep going, it says a random sample of 44. So my n is 44. From that sample, it has a mean sodium content of 925. So my x bar is 925. And the population standard deviation sigma is 18. And at an alpha value of 10%, 0.10, do we have enough evidence to reject the claim? So that's what we're given. So let me switch over here to my actual whiteboard so you can see a little better what's going on. So this is what we have, just getting the information from the problem. If we look over here at our h sub a, right? Remember, h sub a determines the tail. So if it's greater than goes to the right, that means I'm going to have a right tail distribution. All right, in order to find the critical value here, because it's right-tailed, I'm going to take 1 minus my alpha, which is 0.9, because inverse norm will naturally go to the left. So to find my z-score for the critical value, the rejection region, I'm going to take the inverse norm of 90%. So as suggested, I will show the calculator portion of this. I'm going to turn my light on quick. So if we do second vars, let's turn it on first, second vars, go down to number 3, that is the inverse norm. If I do the inverse norm of 0.90, 90%, I'm going to go to 2 places. It gives me 1.28. So when I come over here, my rejection region is formed by a value of 1.28. So any z-scores I get that are in this region, that 1.28 or greater than, I'm going to reject, right? So this, if you want to make a little note, this is my rejection region. This I would fail to reject over here. So if I actually come and do the z-score, just as a quick reminder, we did in the last video, our z-score formula, x bar minus mu over sigma over the square root of n. So if I plug the values that I have in, my x bar is 925. My mu comes from my claim, 920. I divide that by my standard deviation, which was 18, and the square root of n, which is 44. So quickly again to show you, I'm going to group the entire top here in parentheses. So the numerator goes in parentheses as well as the whole thing. So 925 minus 920, close the numerator, divided by open another set of parentheses, 18 divided by the square root of 44. So I'm going to close the square root, close the denominator, close the whole thing. And that gives me a z-score, which is to two places, 1.84. So now that I have my critical value, that 1.84, I can take that and just compare it to the rejection region. So if I take 1.84 and I say, where does it fall on this curve? 1.84 is greater than 1.28, so it's somewhere over here. Because it's in the shaded region, then I make my decision to reject the H sub 0. I'm rejecting the null hypothesis. Now, if you go back, you remember that the null hypothesis, the H sub 0 here, is my original claim. So because we're rejecting H sub 0, we are rejecting the claim that their breakfast sandwiches have, on average, no more than 920 milligrams of sodium. So we reject their claim. So that's all for this video. If you would like, subscribe, and leave a comment. We're always looking for new video topics, so feel free to put that in the comments as well. We appreciate it.